It's been a painful process migrating from single player to multiplayer, but we're still making fairly good progress. Last time I showed the working version of multiplayer where we now have a game server that we can connect to, and that server will synchronize all of the game state so the players can see what everyone else is doing on the map. Since then, I've restructured the game so that each server is in charge of hosting one map and synchronizing the state for that one map, and I've been working on converting all of the game objects to be backed by database models. This way, the server will be able to control what's spawned and the player's gameplay. I wish at this point I'd be able to say that I had a fully working version that matched the single player version and had all the same functionality and actually save the data to the database, but it turns out it actually takes a while. I realized that if I wanted the server to spawn monsters, then I would need to also have a representation of their items that they drop, and that made me realize that I had to do a complete rework of how data is stored in the game right now. Right now, every client has a list of monsters in the game and everything they drop, and it's all defined in the code. But in the future, you'd want to have more control over changing the items that monsters drops, perhaps the monsters' names, their health, and so on, all from a central location, rather than having a copy of that in every single game. So I switched my focus to creating all of the game objects in the database. Before we can talk about the process of creating the game data, let's talk about how the data flows currently. So regardless of if we have any players online, the default state of the game is you have a server that is synchronizing game data with a backend. Then let's say we want to play the game, we open our game client and we make a direct request to the website's backend so that we can log in. And once we're authenticated, then we get information such as where our player was last at, and based on the map that our player was on, we connect to the corresponding game server that matches that map because we have a separate game server for each map in the game. And all this time after the login, we have a loading screen that's being displayed. Once we connect to the game server, that game server sends us the copy of its game data and also issues a request to the website's backend so that we can get the player's data. Once it has the player's data, it sends the data back to the player, and now that the player has the game data and the player data, it can now fully load the game in all its systems and hide the loading screen. And the player will be able to see the map. So far, beyond the initial login, the player doesn't communicate with the website backend. I did this because I don't want the website backend to get a ton of requests from all the players. I want the server to be able to store some of that data and quickly serve it back to the player as needed and make sure there's a lot less load on the website backend. I also want to make sure that only the server has the authority to request a lot of the data. I don't want a scenario where the player is using their authentication tokens to be able to interact with the game's backend and change aspects of the game, either for that player alone or for other people in the game. So that's why I've gated it off so that the player gets all of its data and sends all of its data through each server. So the game server is acting kind of like a cache that stores the game in a well-formatted state. Then we'll also have additional caching that's done on the server to reduce the amount of hits to the database, because those will be much slower data accesses, and it's also much more expensive to have high traffic loads going to a database. I want to make sure that the website backend and the game server are able to calculate any of the stats, the upgrades, the amount of damage a player can do, things like that, so that we always have a sanity check to make sure that players' levels are what they should be. So now for the actual data models, let's talk through a straightforward example like the game locations, the maps that you can go on. And that will help us see the approximate process that I'm taking for over 110 data models. So the very first thing we need is a data model. And for this example, we have a map. We have an index that will tell us the order of the map's name, and then also which zone it belongs to. A zone is essentially a world, and the first world is the Cookie Academy world. So we have another zone model which has its own ordering and its own name. And we connect that map object to the zone object. And from there, for almost every data model, I have to create a database script that will populate the data. So I populate it with all the different maps, and I've made sure that no matter how many times you run this script, it'll only create or update the existing data, so it'll always end up in the exact same final state. You want to write your data bootstrapping scripts like this because you may want to change names and you don't want to have to manually do that every time you start up a new database in a new environment. So yeah, it's pretty annoying to have to write and maintain these database population scripts, but it is saving countless amounts of time for when I want to make changes to how things are structured or when I eventually want to deploy this to production. After that, there's the refactoring step where we want to go back to the game's code and modify and restructure it so that it can take in however we have structured the data model to be. There have been plenty of times these past 2 weeks where I've realized a better way of restructuring and reusing data models, and I've taken that time to do huge refactors. Then we create the API endpoint that stores that game data, or we modify an existing one to be able to also send that new data. This is for when the server is grabbing the data from the website backend. Then once again, we change the game server and client code to be able to read and store that data. And finally, we delete the old implementation of the game where perhaps we had different lists of the game data that were hard coded into the game, but now we're reading it from the database instead. I've staged it in these concrete steps because, as much as possible, I want to make sure that the game is in a working state or can quickly return to a working state as I do this major refactoring to make everything multiplayer compatible. As for the current progress, I mentioned that there's over 110 data models. Initially, I just started going through the process for each one and doing the refactor, but it was taking forever. And it's really hard to stay motivated when you're working on a long task and it doesn't feel like there's many new things that are coming out of it. So, a couple of days ago, I made a chart of the current progress, and each row is a game feature or data model that we need, and each column represents one of the approximate steps in the process. Green is for everything that I've completed, and then we have the blue shade for things that don't necessarily apply for that step. So, you can see I've made pretty good progress so far. I've completely finished the data model creation and populating the database, and now I have to do a lot of refactoring and deleting of the old implementation, which I think will be an easier process now that we have the models in place. After these charts are fully green, unfortunately, there's still more work we have to do to make it so that we have the same kind of functionality to be able to store things in the inventory, collect experience, things like that. We'll only have the ability to read in data. We also need to be able to create, update, and delete data. So I'll be spending a lot of time creating a ton of new API endpoints, and hopefully I'll be able to restructure it so that each game component on the server can manage the corresponding player data rather than having one huge file that is managing all of the different kinds of player data in the game. Now, switching gears a bit, last week I talked about creating a new game server for every map for the player to connect to so that each server essentially has a copy of the game that is only running one map. I did find time to work on that a couple weeks ago. I exported the game so that we have a game that can run on the Linux operating system, because a lot of the cloud hosting services use servers that are running some version of Linux. And I've also stored the game in file storage on the cloud. And then to actually deploy the game to the server, I've created a new Docker image, which is essentially a container that holds all of the logic needed to download the game and run the game regardless of where it's deployed. So this container will essentially launch that Linux game several times, one for each map that it's controlling. And on any given computer, it has thousands of ports, and each program can listen on a different port. So I've set it up so that each game server map is listening on a different port, and then the player knows which port to connect to based on which map they want to connect to. This allows us to only have to pay for one machine to run several versions of the game on. And then from there, essentially, you have your game server that's in the cloud, and you as a player can connect your game client to the remote server. I just went through that workflow to make sure I could do it down the line, but for local development, everything's running on my computer because I don't want to have to release a new version of the Linux game, redeploy on every single change that I make. So that's where I am right now. Unfortunately, no shiny new features, but all very necessary work. In the meantime, I've been watching a ton of anime, and I've noticed that a lot of them have really good cooking animations and scenery. I watched Skip and Loafer this past week, and not only was it such a feel-good and wholesome and extremely healthy show with great character development, but it also had epic food animations and really great flowers throughout. I definitely recommend it if you haven't seen it. I think it's some of the healthiest relationship dynamics that I've seen portrayed in a show in a long time. Whenever I see cool scenes, I always pause and screenshot it, and hopefully in the future, when I get to the point where I'm animating for the game, I'll be able to take some inspiration from how these shows have animated things in a simple or complex way. Of course, a lot of these shows have been developed with each episode taking a month or so by a team of tens of people, so I'm not expecting myself to be able to develop the same kind of animations in the future, but I think it's still really cool and inspirational to see regardless. So that's all for today. Thanks for taking the time to watch. Subscribe if you'd like to continue following these game development updates, and I will see you in 2 weeks with the next one.